cells, fuel cells, secondary batteries, supercapacitors, air and water purification, and removal of air pollutants. On behalf of organizing committee, I take this opportunity to welcome most eminent scientist, Professor Pramod Patil sir, Honorable Professor Pramod Patil sir, Pro Vice Chancellor Shivaji University Kolhapur, who in spite of his busy schedule accepted our humble invitation as the chief guest of inaugural function and delivering keynote address in the conference. I welcome you, sir, on behalf of Department of Chemistry, Lal Bahadur Shastri College of Arts, Science and Commerce, Satara. Sir, we are proud to be here with us and all are eager to listen your keynote address. I am thankful to the particularly Sanstha authorities, Honorable Principal Abhay Kumarji Salanke, Chairman Sri Swami Vivekananda Shikshan Sanstha Kolhapur, Honorable Principal Shubhangi Gowde Madam, Secretary Sri Swami Vivekananda Shikshan Sanstha Kolhapur, and Honorable Kaustubh Gowde sir, CEO Sri Swami Vivekananda Shikshan Sanstha Kolhapur for constant support. I welcome President of today's function, most dynamic and enthusiastic personality, our inspiration, guide, motivator, Honorable Principal Dr. R.V. Selva sir, Joint Secretary Sri Swami Vivekananda Shikshan Sanstha Kolhapur, and Member of Management Council Shivaji University Kolhapur. We have today with us Dr. Santosh Patil from Femto ST Institute, France. Sir is actually postdoctoral research scientist. I welcome you, sir, on behalf of Department of Chemistry, Lal Bahadur Shastri College of Arts and Science, Satara. Now, in today's conference, 3 online lectures are there. I also welcome to Dr. Thillai Shiv Kumar Natarajan, Environmental Science Lab, CSR Central Research Institute, Chennai. Sir is going to talk on solar. Sir is going to talk on particularly solar light response to nanomaterials for sustainable and clean environment. Another lecture is Dr. Naresh Kutla, Department of Bioscience, University of Oslo, Norway, and sir is going to talk on the nanotechnology and nanomedicine for biomedical applications. And last lecture is Dr. Srinivas Mashimuku, National Cheng Kung University, Taiwan, and he is going to talk on the 2-dimensional nanomaterials for advanced catalysis. Finally, I would like to thank all the participants, volunteers, and teaching and non-teaching staff who is actually contributed to the conference. My special thanks to all my MSc students for their constant efforts for the success of seminar. Thank you. Thank you.
Now I would like to request Dr. R.V. Shezwar sir, Secretary Administrative of Sri Swami Vivekananda Shikshan Sanstha, Kolhapur member, Managing Council, Shivaji University Kolhapur, to felicitate today's chief guest, Professor Dr. P.S. Patil sir, Pro Vice Chancellor, Shivaji University Kolhapur. Femto Institute, Science and Technology, France. Now I would like to request Dr. R.V. Shezwar sir to felicitate Dr. G.S. Kamble sir, co-convener of the one-day international conference on nanomaterials for energy and environmental applications 2023. Now I would like to request Vice Principal Dr. Shipi Mani sir to felicitate Principal Dr. R.V. Shezwar sir. Now I will request to Dr. A.M. Nalawade sir, convener of ICNIA 2023 Palisade, Vice Principal Dr. C.P. Mani sir. Now I like to request Dr. D.V. Rupnavar sir to Palisade, Head of the Chemistry Department, and convener Dr. A.M. Nalawade sir. We have received tremendous response for this conference across the country and world as well. There are numerous abstracts received from participants. Hence, we are going to publish such abstracts in the form of souvenir. So, I request to all the dignitaries on the dais to publish the souvenir. Thank you, sir. It is pleasure to invite today's chief guest, Honorable Professor Dr. P.S. Patil, sir, Pro-Vice Chancellor, Shivaji University, Kolhapur, to express his views about today's World Day International Conference on Nanomaterials for Energy and Environmental Applications, ICNIA 2023, and also give keynote address.
Hello, good morning to all of you. The president of today's function, the management council member of Shivaji University, the principal of this college, Dr. R.V. Shezwa, sir, vice chairman of this particular conference, Dr. C.P. Mani, the convener of the conference, Dr. A.M. Nalawade. Here we have a special invited speaker from France, and he is our own student, Dr. Santosh from FEMTO, Institute of Science and Technology, France. He will be talking on hybrid nano architectures for energy and environmental applications. The faculty members of this particular college and my dear participant friends, I am indeed very happy to be here on the occasion of inaugural function of the one-day international conference on nanomaterials for energy and environmental applications, organized by Lal Bahadur Shastri College of Arts, Science and Commerce, Satara, in collaboration with Department of Chemistry, KIT, College of Engineering, Kolhapur. In fact, it is a very good idea to combine one science college with the engineering college and organize a conference on interdisciplinary and multidisciplinary area like nanomaterials and nanotechnology. Now the days have changed. Earlier, when we were a student, MSc student or research student, we were working in a particular domain of the subject. The student of physics department was not knowing anything about the chemistry, the student of chemistry department was not knowing anything about the physics and areas of research in physics, and forget about the life sciences and biological sciences. Nobody liked from A group, nobody liked the subjects of B group, and vice versa. The students of B group did not like the subjects of A group. So the students of botany, zoology and biotechnology did not ever like statistics, mathematics and physics. But now it is high time that everybody should come together and discuss one topic from different angles, from different perspectives. And that is nanotechnology, that is nanoscience and technology, in which we need knowledge, we need to put in a lot of efforts in research to discuss many ideas related to nanoscience and technology. Because nano start itself with the mathematics. What is nano? Is 10 raised to minus 9 meter. 1 nanometer is 10 raised to minus 9 meter, but in other words, you can call it as a 1 billionth of a meter. So you must know, the students must be well aware of some of the mathematical terms like million, billion, and not like lakhs, because lakhs is the word used only in the country like India. Other people talks about the million and billion. So when you talk in terms of science and technology, and if you want to express 10 raised to minus 9 meter, it is 1 billionth of a meter. 1 billionth means 10 raised to minus 9. 1 billion is 10 raised to plus 9. Okay, so from there itself, from the definition of nanotechnology itself, mathematics starts. And you can explain many different things of nanoscience and technology, properties of the nanomaterials in terms of mathematics very well. One equation is worth 1,000 words. So you need to learn these mathematics and equations by heart. Even though you are from chemistry or physics or biology, you should know what are those equations, because those equations are very, very prevailing. Those equations are very, very important. With the help of those equations, you can explain the properties in a better manner. So whether you are a student of physics, chemistry, biotechnology, it doesn't matter. We should start from these little simple basic things about the mathematics. And then comes when you want to analyze the results, the knowledge of statistics is very, very important. So you should know a little bit of statistics. Therefore, our structure in the FYBSc, SYBSc, we have 4 different subjects like mathematics, chemistry, physics and statistics or electronics. These particular subjects will impart you a basic knowledge that is very, very important for you if you decide to do your career in research. If at all you want to become a researcher or a scientist, like Dr. Santosh is sitting here, you need to know at least little bit of all the subjects. And okay, by heart. Okay, and that is very, very important. And if you know all the flavors of all these subjects, you can think differently. Today, we need students, we need researchers that can give us different things, unique things, so that we can develop our products, we can develop our technology indigenously. It should be import substitute. It should be commercially viable. It should be low cost. And for that, we need to imbibe many things in the brains of our students. We need to teach the students how to create rather than how to copy. Many a times, when you look at your own house, what are the products that are there in your own house, like television, microphone, microwave oven, fridge, this and that, and even coming back to your smartphone. It is all not made in India. It is all imported, right? Either China or Japan or America. So therefore, our students need to think about that. Many times we notice it, but we ignore it. What we need to know, what we need to do is every student has to be converted into curious student. Curiosity is very, very important. Inquisitiveness is very, very important. Therefore, if you are curious, if you are inquisitive, you start asking questions. Learning by asking questions is very, very important. To whom to ask the question? You have your teachers, You have many things. Now internet is in your fingertip. So you can ask questions to Google. You can even ask questions to ChatGPT. How many of you know ChatGPT? Just raise your hands.
ChatGPT.
Only few. Okay, good. But you will be able to understand, you will be able to know about ChatGPT very soon. It is growing at a very, very fast rate. It is growing. Maybe next year, if you call me, I will be talking on ChatGPT. It is so hot topic today because if you ask ChatGPT to write essay on nanotechnology, it will write for you. If you have some results on nanochemistry, ask ChatGPT to write a paper on nanochemistry. That particular software will write a paper for you. And you can use your name, Dr. Santosh Patil and ChatGPT as an author. That is now possible and that is now valid. And many good scientists, even they are using ChatGPT as an author. But you have to use it carefully. You have to use it only as a tool. Just like smartphone, we are using as a tool only. You can use ChatGPT as a tool only. For example, if I would like to work on metal oxide frameworks for energy conversion. Okay? So for that particular thing, you have to start from survey of literature or review of literature. Review of literature consists of several thousands or several hundred thousands of papers on the Scopus. How it is not possible for us to take a review of all these papers in a short time. Okay, you may need at least 6 months or at least 1 year to go through all the important milestone papers, classic papers which are there in the metal oxide frameworks, like who has invented metal oxide framework? What was the first material that has been used to create metal oxide framework? Why only this material has been there? Why not other materials have been used to convert into metal oxide frameworks? Is it really possible to develop MOF, that is metal oxide frameworks, with n number of materials or only specialty materials? All these questions should come into mind. And if you want some answers very easily, ChatGPT is there. But what I was talking to you, you just tell the ChatGPT that what are the materials used for the metal oxide framework and who invented metal oxide framework. The ChatGPT software will tell you all the things. So it will give you an essay and write-up in which everything is available, and that is the extract. Intelligent extract of about 1 lakh of articles which are there on the Scopus. Of course, the papers which are published in the international web only it will read. If you publish a paper in simple journal which is not globalized, then it will not capture. But that is not that important. What is important is a global knowledge, global database, and that global database is scanned by the ChatGPT, and it will give you an entire review of what has happened. Now, from there, your role starts. This is the background, this is the survey, and this is all the research that has been already been done by the scientists across the world. Then what is my role? What I should do? And for that, you need to think. Okay? And there comes a uniqueness. And if you write without taking notice of the literature which is already published, and if you write something just by copying and pasting, it comes under plagiarism. Plagiarism is come up because there is again a software which is called as a Turnitin software. Even though you just copy 4 or 5 letters from any sentence, the referee, international referee, or any standard journal will notice that you have just copied and pasted, which is not allowed in the scientific fraternity. In the scientific fraternity now, the weightage has been given to a very, very original literature that should be your own creation, that should be your own research rather than copying and pasting or following anyone. That should be your own research, and that is the challenge in front of entire students fraternity, that how to conduct a novel unique and out-of-box research. If you do that, then you will get some particular direction, and that direction will take you to a higher and higher level, and you will become a very big scientist. Okay, so this is now some of the challenges and excitements in research currently that we are facing. There are challenges, but there are excitements also. Because, as I told you, earlier there was no access to the intelligence software like ChatGPT. But now you have that particular ChatGPT access. You can take advantage of that as a tool, just like smartphone, and use those particular tools for elevating standards of your own research. Okay, just like you have a very good laboratory will help you. It will save your energy. It will save your time. When I was doing my PhD, even just for recording one X-ray diffraction pattern, I have to go to BRC Mumbai, Bhabha Atomic Research Mumbai, for recording a single X-ray diffraction pattern of my one sample that I deposited during my PhD in 1988. I am talking about 1988. Those were days where we used to go to BRC just for reading one good or recent journal. We used to go to National Chemical Laboratory, Pune, NCL Library, and for many other like simple things, UV visible spectrum, FTIR spectrum, Raman, that time was very, very rare. We used to go to RSIC Nagpur. So that was in a way good, in a way it is not good also. What was good? Good that we went to each and every labs of the premier institutes like IITs or NITs or RSICs. That by that way we knew what is happening there, what are the students working there. They became our friend, we became their friend, and their guides also became our friend. So that is the entire research and innovation ecosystem in the olden days. Though we used to spend months of time to characterize my material by going outside without having any money in the pocket, but borrowing some money from the friends. We used to go there through bus and wait there for days and getting the particular thing. So now that particular period has been shortened. Even in your laboratory in the college, you have UV visible spectrometer. You have FTIR. Workstation is there, electrochemical?
Yeah.
See.
AS is there.
Atomic absorption. See. Yours is like a mini university now. So you have to convert this college into a mini university. Even in YCIS, you can go, they also have many facilities. Same, they have scanning electron microscope. I installed one scanning electron microscope in the Department of Physics in the year 1999. And that particular scope is working till today without any problem, and the credit goes to my all PhD students. I did not appoint any operator for operating that machine, only that was a training imparted to the PhD student, led a very nice seamless operation of ACM. Day and night we were working on that because that was my dream. When I was doing my PhD, I did not have access to ACM. I used to go to Nagpur. You know, Nagpur, it takes about 36 hours by Nagpur Express, Maharashtra Express. So that was the technology that was needed that time. The machines that we were needed that time. Now we have all established laboratories for you at your doorstep. Now your role is very, very important. You should go there. Sir told you, Fourier transform infrared spectroscopy, FTIR. Why it is Fourier transform? What is infrared? What is the wavelength range of the infrared spectrum? And why only infrared? All these questions should come to your mind. As a student, you should ask thousands of questions to yourself. That is the way in which we call as a learning by asking questions. There was one scientist who invented this MRI, magnetic resonance imaging, Professor Isaac Rabi. He was a physicist, and when he received a Nobel Prize, many people, journalists, asked questions, to whom do you dedicate this particular award? He said, I would like to dedicate this award to my mother. Then he asked, why, sir? What is exactly the motivation given to you by your mother? He said, when I was a child and going to the school and coming back from the school, she used to ask me one question only every day. Did you ask question today? That was the question that my mother was asking every day. That inculcated her habit of asking me questions, inculcated the habit of asking questions. So I started trying. I tried to ask questions, but it was difficult to ask questions. Because then I understood that if you really want to ask questions, you have to understand what is being taught by your teacher in the classroom. And if you really want to understand, you have to be well versed with all the background knowledge. Then you have to read that. Rather than mugging, you have to read and understand. And then you go to your class, and then you will understand what your teacher is teaching you. From that, you can, because of your curiousness, because of your inquisitiveness, you start thinking of what do you say? You start thinking in a speedy way, maybe ahead than your teacher. Then probably you may ask questions. Did you ask good question today? That was the question his mother was asking, and he inculcated the habit of asking question. Today there is a need of telling our student really to ask questions to yourself, and if you really ask question, you have to understand each and every lecture given to you without bugging, without bunking. You have to attend the lectures regularly. You have to keep a track of the teacher, and whenever you feel that yes, this is something different that I was not thinking, you can contact your teacher and ask the explanation of that. If it is not possible because of many reasons in India that we have many students and teacher is one or two, then you can ask Google and get the answers, get clarification done. But what we do, we don't have time to ask questions to Google, but we keep on doing that, and finally we don't understand anything. We mug. I always call this system as a 3R system. Read, remember, reproduce, and forget. Read the notes given by the teachers. Remember just by asking, just by reading it for several times. Remembering, reproducing in the examination the same thing which is there, temporarily stored in brain. And once you have written your answer book, come out of the hall, the knowledge is volatile, it will escape. Therefore, then you will not be able to apply your knowledge. If you understand and absorb the knowledge, if the knowledge is absorbed within you, you will be able to apply that knowledge. Unless and until you absorb the knowledge, you will not be able to apply the knowledge. Like chemistry is a very important subject for me. There is a chemistry everywhere. Right from your kitchen, chemistry starts. Right? So, have you thought about the chemistry of the milk? Have you thought about the chemistry of the curd? And so on and so forth. You said, yes sir, it is very simple thing, but think ahead. Think ahead. Some simple chemistry is there, how to convert curd from the milk. Okay? By fermenting. Fermentation is very, very simple thing. It is known for several hundreds of years. But do you understand that particular? Have you written down some reactions? Have you found out some opportunity for you to innovate from that equation? Very simple modification, can you do that? Many dairies, like Amul dairies and others, they do innovations. How a curd, which is packed in simple package, with is there in the malls for say 1 month or 2 months. In the house, if you keep this particular curd open, it will be spoiled. But in the mall, it remains same. It is very, very tasty. It is very fresh. Even after 1 month. What is the difference between our ordinary homemade curd and the curd that is made by the Amul dairy or Spurti dairy, which is there in Kolhapur? What exactly is the differences that we have made? What exactly is the innovation that in the process that they have added. And even though it is, again, it is known thing, it is documented thing, it is their research, but there is no harm in going into that particular details and find out how a curd can remain for about 1 month or 2 months afresh. And then you can invent something. If you are curious, if you are inquisitive, you can add up your own flavor into it. Can you have a flavored curd or flavored curd milk? Simple things are there in chemistry. It doesn't make, it's not like a rocket engineering. It is a simple chemistry, but that requires beyond thinking, out of box thinking, with few additional innovative steps. You can convert, you can add value to the product which is already there in the market. And many examples you can see if you open your eyes and see around. Like in Satara, there is Kandi Pede, which is very popular. What is the chemistry of Kandi Pede? Why does that particular taste is there in Kandi Pede? Why Dharwad Pedes are different than Kandi Pede, Satara? There is a chemistry, because it is a food has a chemistry. So what particular flavor that has been added by Dharwad people that is not there in Satara Kandi Pede? What is there in Dharwad Pede is not here. What is here, it is not there. So some change may be there in the chemistry of peda making. Probably you may find out some different flavors of Satara Kandi Peda, but we have to think innovatively, we have to think out of box. Today we need ignited manpower. Today we need creators, not followers. And the students are creators. They can be very good creators provided you are curious. Okay? Curiosity is very important. Even Albert Einstein, why he is called as a scientist of the millennium? He was even denied the teaching job at the high school. But then he became scientist of the millennium. Why? Because he said, I am not smart, but I am passionately curious. So you have to be not only curious, but passionately curious. Curiosity should be your passion. Is it really? Then you have to think on your own. I'm just telling you different things, but you can pick up any idea and start developing your own things. So whether you are passionately curious, yes, then go ahead. No, go to some other areas like trading, businesses, tallies and commerce and management. There is also a lot of scope. Every domain, they have opportunities. Since you are all the students and researchers in the domain of chemistry, research, I am telling you all these things, but each and every domain is now full of excitements. Just like, during the last 2 years, we faced a problem of COVID-19 pandemic, right? But now we have won the battle against COVID-19, right? That's why we have no mask. We are not using sanitizers today because we have won the battle against COVID-19. Ready? And during COVID-19, what you did? Can you tell me what you did during COVID-19 pandemic? Did you attend any classes? Yeah, offline classes? No. Did you go to market? No. Did you go to shopping? No. Did you buy anything? No. But you just kept quiet at the home because you were quarantined. Okay? But that gave opportunity to some other bright youngsters to innovate something. That was the problem to us. But the opportunity to some bright students. They took an opportunity, they converted that difficult situations into opportunity, and they did their businesses in a better manner. They started developing simple sanitizers, they developing masks, and they started developing many other things which we started using by sitting at the home. But they made the business because of their inquisitive manner, because they were curious and they wanted to take the advantage of that particular situation which was there once in a lifetime. And many people became billionaire. Those days startups came, about 40 startups are reported in the country during COVID-19, which were now called as a unicorn companies. Unicorn company means the turnover of that company goes up to 1,000 crores of rupees annually. So those youngsters, they did business because they were curious. Not only curious, they were passionately curious and they wanted to convert those difficult situations into opportunity. We, sitting at Shivaji University, also started developing something, and some of the products are there in the market, and we did an accelerated research. Today what we are doing, we do research, but the result comes, a viable and valid results come after 5 years, 10 years. We are not bothered about, and we are not in hurry about the research. We are not worried about the output. We are worried, but many other things are there. But in the COVID time, we had no option. We means all scientists had no option but to do and conduct accelerated research. Accelerated means do it day and night. Do whatever you want to do, but we need results within 1 month or 2 months or 6 months. And that is the way we also started at Shivaji University. Kolhapur, fortunately one company in which we had a collaboration earlier, they came to us on phone, they told me that, sir, we have this particular idea, can we do it? If your lab is open during COVID-19, all the labs in Pune are closed, NCL is closed, ICT is closed, but if there is some mild situation in Kolhapur, relatively milder situation in Kolhapur as compared with Pune and Mumbai, can we open your lab and do some research and can you invite some students? But I told him that already our lab is open. We are developing some chemicals and sanitizers and masks which were embedded and impenetrated with the nanoparticles, silver nanoparticles penetrated into the mask, and that is antibacterial. We are already doing that. Then he came over in a car, Ecoscience Private Limited, businessman and industrialist, sorry, not businessman, and we started developing the formulations for the antiviral spray. So if you have a bottle, perfume bottles, so finally our researchers did it. A team of 10 students and 2 teachers did it day and night. We supplied everything. We took permission from the registrar of the university and they did research day and night in the laboratory, and finally they came out with the solution which they called as an antiviral solution, and it was filled into the spray bottle, and you just have to spray on your coat, like this is a coat, you spray it. It forms a very simple nano thin film on the surface of these textiles, which was eventually antiviral, and it was killing the COVID-19. But how to prove that this particular coating is killing COVID-19 and how to conduct that particular practical in India? Because there was only one institute in Pune, which is the NIV, National Institute of Virology. We contacted them. They said they were not even ready to pick up the phone because for them treating the patients were much more preferential job than doing research. So they said, no sir, we have waiting, we cannot test it for say 2 years or 3 years, it is not possible. So we send it to USA. There are some specialized labs to test viruses. And that lab was there. I forgot that BS4 standard lab was there in USA, California. Unfortunately, we could get the results from there and we proved that yes, it is antiviral, and now that particular product is available on the Flipkart. That is the product of Shivaji University in collaboration with that particular Ecoscience Private Limited. That is available, and that is the output of hard work and curious work by our students, research students. That is there. You can also do that. But now there is no COVID, then you will ask her what I can do now. There is no COVID, but if there is no COVID, there are many other things. Only things that you will be able to see that if you have that perspective of looking at the problems. If you don't have the perspectives of looking at the problems in a different manner, you will just be a follower. You will just be a copier. You will not innovate anything new. Okay? So if you have that particular perspective, you will be able to see to a particular thing in a different manner, different angle, different dimensions. We need to imbibe that particular habit of looking at looking at the society in a different perspective. That is possible, and that is, I think, the aims and objectives of the conferences like this. We would like to give you different perspectives of looking at the problems. Currently, what is our problem? Identification of the problems in the society itself is a problem. Many years ago, we started developing interactions and linkages with the industries in and around Kolhapur, Satara and Sangli districts, but that was not happening. We invited many industries, but they talk different language. Our teachers talk different language. Teachers talk about the syllabus and workload and the students, but the industries talk about the product, value-added products, margin and market of that particular product that we never talk. We miss teachers. So how to marry these two different things together? So why not our students and teachers come together and start doing and developing the products for the industry? What is the gap exists between the academy and industry? That was the problem given to our university industry interaction cell by us. For the last 2 years we are working on that. Then I realized that nobody will tell you the problems. If he is industrialist, I am a teacher and I go to him, sir, what is your problem? He will not tell you what is the problem of industry. It is not that simple. It is not that casual. If you have casual approach, nobody will come forward and tell their questions. They will not tell the questions and problems with them, their industry, unless and until you prove yourself and they are confident about you. They will not tell. मी मराठीत त्यांना म्हणत होते इंडस्ट्रीच्या पोटात घुसलं पाहिजे तरच त्यांचे प्रश्न तुम्हाला कळतात असं मराठीत मी सांगत होतो. And then we started one project, prototype projects with this particular intention, knowing the problems in the industry. We started going to the industry. We developed a team of teachers and we told them that every day, at least 1 hour, you go there, interact with the people, interact with the faculty, interact with the workers in the industry, interact with the industrialists, and interact with the R&D team of the industry. We did that for about 6 months and 1 year. 1 year of incubation period was needed for us to understand what they are doing in the industry. It is not simple. Understanding industry as a layman is different, and in the understanding that industry from the chemistry point of view is different, physics point of view is different, mechanical engineering point of view is different. So, in what perspectives, from what dimension you would like to see to the industry as a chemist, as a researcher in the chemistry, or as a engineer like him? He is a chemical engineer. But for that particular, you need at least 6 months to 1 year. Then they started believing in us. They knew that we have well set lab in the Shivaji University. They visited, they saw. They also saw our style of working. They also interacted with our researchers, research students, and they finally got the confidence on us. Okay, we developed confidence in them, and then they told me that this is the problem. And that problem was not a vague problem. That was a very pinpointed problem that they told us. That was the problem given to us by that particular company that they have not given to anyone, anywhere before that. Because they did not have any confidence about the researchers. They were relying on the research company in Germany and in UK. They were telling them all the problems, thinking that they are able and they were confident about them. But they were not telling us. The university, which is 4 kilometers away from the industry, there are researchers, there are teachers, but they were not telling their problems to us. But they were telling these problems to the teachers and scientists who were sitting 8,000 kilometers away from Kolkata. That is the link, that is the confidence that you need to imbibe into the industrialists. Then only they will come and tell you pinpointed problem. What was their pinpointed problem? They needed the coating which can withstand about 1800 degrees Celsius. Because they were into foundries, they wanted to lift molten alloy and put it into the things so that they can make a wheels or bearings and many other automobile parts. But the spoon that they were using at a high temperature, there was a special coating done by a German company that was withstanding only for 1 week. Only 1 week. But they wanted to have different coatings which will have at least a lifetime of 15 days at 1800 degrees Celsius. Then we accepted that challenge, and by trial and errors, at least we knew here is the way. I started tomorrow morning from my own house, but my target and destination was clear. I have to go to LBS. In research, there also you need to know your goal and destination. So we needed that particular direction, and we got it, that we wanted to develop this particular coating which can withstand for about 1800 degrees Celsius. Then we started developing the technology, and finally we could succeed. They tested it for several months together, and they finally told that, sir, your coating is far better than the German coating. We have that potential. We have that potential, but we need to have that confidence to work in the close vicinity of the industry for their problems. So you can use your intelligence, you can use your intellect to solve their problems. And for imbibing that particular level of intellectualness, you need to attend the conferences like this. And now we have signed, we have even transferred the technology to them. The transfer of technology happened for the first time in Shivaji University after 60 years of research training. How many companies are coming? Breaking the ice is very difficult. There is always a bottleneck that you need to break. If you break that particular ice, if you break that particular bottleneck, then there is a plenty of opportunity for you. People start believing in you, they have confidence in you, they approach you. Rather than you go there, they will come to you. And now we are setting up a separate domain facilities for that particular industry in Kolkata. So we have now close rapport, and we have also submitted several common and different projects which are collaborative projects. Yesterday, even today, 4 o'clock, we have to submit one project which is called as a DST Sati project. At 4 p.m. I should be there for going back to Kolhapur well in time, because 5 institutions have come together. It is a multi-institutional program. Just in the beginning of this particular talk, I was talking about the different subjects, but now I am talking about the multi-institutes. Different institutes we have come together. 6 different institutes have come together, and we sat together and we wrote one project under DST Sati, which the maximum outlay of that project is 60 crores. Their only condition is that university should put 5% of 60 crores. So we have a cluster with Pune University, then NCL and ICT and Shivaji University. We have decided before your management council, now sir is a management council. If there is a problem of money, management council has the right and authority of sanctioning that money to us. So earlier management council has already given from Shivaji University, we are contributing 5 crores, we are contributing, and DST will, if it is sanctioned. So today is the last day, we are submitting that PPTs, and on 4th of May, 4th of April, there is a presentation in Bangalore. So this is all fascinating things. If you have idea, you can tell and convince the people so that they will give you a lot of fundings. Not only in thousands, not only in lakhs, but in crores of rupees. You will get the fundings for for converting your dream into reality. It is possible. That was also my dream when I was like you. And now we have a very well set world-class laboratory of rupees 100 crores. I started with 1 lakh, now we have about 100 crore lab. It is a sophisticated analytical instrumentation facility with all X-ray photoelectron spectroscopy, transmission electron spectroscopy, high energy X-ray diffraction pattern. Each and everything is there. If you name the instrument, it is there. Raman is there, photoluminescence spectrophotometer is there, time results spectrophotometer is there. SEM is there, FESEM is there. Now I am telling to our student is what is the use of SEM and why we need FESEM. What is TM and why we need FET? Why do we need field emission? FE means field. If we need field emission, what was their earlier version? There was no FE, SE written before SEM or TM. It is just SEM. What particular technology that particular SEM machine has been involved for emitting electrons? What was that? There is no name. But do you know that physics? Do you know that technology? Do you know what physics has been used to emit electrons? Because electrons are necessary. That is going one step ahead than the photons. If I use photons and if I use a scope to visualize the things, to magnify the things, that is called as an optical microscope. Optical microscope works only in the light. Photons are right. So what is the wavelength of the photon? Do you know electromagnetic spectrum? Gamma ray, X-ray, UV, visible, IR, NIR, microwave, radio wave. Do you know the unit of wavelength? Angstrom, nanometer, micrometer. If the wavelength is 4000 angstrom, can you convert it into nanometer? Again, basic mathematics. 4000 angstrom is equal to 400 nanometer is equal to 0.4 micrometer. हे सगळं तुमच्या डोक्यामध्ये असलं तर स्पष्ट होते आणि समजते. Okay, you can see the photons which actually are invisible. If you are curious, if you are good, if you are intelligent, without looking at the particular things, you can see the things. Okay, that is the real research, and that will imbibe a different perspective. See. So, what I was talking to you about the optical microscope, that resolution of the optical microscope is equal to lambda by 2 into numerical aperture, which is normally approximately 1 in air. If I have oil, it becomes higher than that, but we use always air, so lambda by 2. And shortest wavelength in the visible radiation is 400 nanometer. So 400 divided by 2 is 200 nanometer. That is the resolution limit of the optical instrument. Optical means photon. So we need 1 nanometer, but here we have 200 nanometer. How to look at 1 or 10 nanometer? It is very difficult with the help of optical microscope. So what we need, we have to imagine. We have to think differently. We have to take one step ahead based on our knowledge, and knowledge that we have absorbed during our classroom will be useful here to tailor different microscopes for the fraternity to have resolutions in the nano regime. So for that I need to remove photons and use electrons. Photons, you cannot change the wavelength. Can you change the wavelength of photon? No. If I cannot change the wavelength, I cannot change the energy. If I cannot change the energy, I cannot change the frequency, because there is a relation E is equal to hc by lambda. Everything is related. Energy, velocity, wavelength, frequency, everything is related. So if you cannot manipulate, if you cannot control one thing, you cannot control anything. I cannot make the photon a shorter or longer. One photon of 400 nanometer, I cannot change its value, but I can change the wavelength of electron. I have a fan. There is a fan. Why do you like fan? There is a speed, right? I like it. Thermostat आहे बघा घरात. त्या thermostat वरून बरंचसं शिकण्याचं. Zero speed off. 1 slow, 2 जरासा fast. So that manipulates the speed of the fan. You can control the speed of the fan just by rotating the knob. What it gives you? It gives you the sense of controlling the speed of the fan. You can control the speed of the fan as per your need. If today I am sweating, I can put it on 5. If I need some cozy atmosphere, I will put it only on 1. If I don't, it is very cold, I will put it on 0. It is in your hand. But photons are not in your hand. Electrons are there in your hand. Because with the help of, just like thermostat, it is a thermostat with the help of which you can increase or decrease the wavelength of photons. Electrons. But not photons. And that is simple, like adjusting the fan speed. It is simple. You can prepare, you can emit the electrons with very longer wavelength, or you can reduce the wavelength of the electron just by rotating the knob, clockwise or anti-clockwise. Because the wavelength depends on the accelerating voltage, and what you are rotating the knob is that means you are changing the magnitude of the accelerating voltage that eventually has been applied to the accelerating tube, where we have cathode and anode. So what I need is a pipe. On the top end we need a cathode. On the bottom end is your film or the sample. We need one top, that is a cathode which can emit electrons, and that electrons will be emitted just by rotating the knob. It is very simple. And you can change the wavelength of that electrons by rotating the knob. So we can control the wavelength and frequency and energy of the electron, which is not there in the photon, and therefore there is a whole range of microscope which uses electrons rather than protons. And those are called as the electron microscope. So I have scanning electron microscope, FESEM, that is field emission scanning electron microscope, and many other microscopes, transmission electron microscope also. So there is a lot of physics which is written in the textbook, but you can see and look at the instruments where the physics is acting there. We know the equation, we know the band diagram, we know the block diagram. Electrons are emitted like this in this particular diagram. We read everything in the notebook and book. But then you go to the microscope and you experience how the physics is in the action. Even though you cannot see the electrons, you will feel the electrons. Because the electrons will be incident on your sample, they will be reflected, they will be scattered, secondary electrons are ejected, and you need a very intelligent detectors which can filter out only secondary electrons. It will sense the signal emitted by the secondary electrons and the distribution of their electron energy densities. You can see the SEM pictures. Whether it is 2D, 3D or 1D, it is two-dimensional nanosheet or hierarchical metal oxide frameworks or a cage or simple 3D networks or tubes or wires. Okay. What is there inside your sample is magnified several lakhs of times by the electron microscope, and you can see that. These are some of the areas with the help of which you can see inside your materials in 100,000 times more magnification, and then you will understand what I have prepared, which material I have prepared. That material cannot be seen by simple general man, but you can see through optical electron microscope, and you can understand because you are a researcher. Now, why I need a field emission? Because there are some delicate samples. Tomorrow, if you develop some sample like polymers or some delicate soft materials, and if I use 30 kilovolt, 30 kilovolt म्हणजे किती झालं? 30 किलो म्हणजे अजून 1000 म्हणजे 30,000 volts. बल्ब कितीवर पेटतोय? 220. Here I am using 30,000. इमॅजिन करणं पण महत्वाचं आहे. 30,000 वोल्ट आपल्याला इमॅजिनेशन नसेल, अंडरस्टँडिंग, तर हात लावू शकतो. हाय व्होल्टेज आपली जाते ना लाईट, ते तर एकदम हाय व्होल्टेज असते, ते त्याला हात लावू शकत नाही आपण. तसंच इथं जो काही बीम आहे, एनक्लोज चॅनल आहे, त्याचं 30 किलो व्होल्ट म्हणजे 30,000 व्होल्ट तिथं असते. पण तरी सुद्धा तुम्ही असं 30,000 व्होल्टला करू शकता. ती टेक्नॉलॉजी. Why we need 30,000? As the higher is the voltage, shorter is the wavelength, better is the resolution. Okay, and that is why we need higher energy. पण जर पॉलिमर किंवा सॉफ्ट मटेरियल असेल आणि हायर 30,000 किलो व्होल्ट मी सोडलं तर ते बर्न होते, मटेरियल स्टार्ट बर्निंग. And if the material start burning, you will not get good pictures, and your film will be ruptured, your material will be break down. So you need the same resolution at lower voltages of 10,000 it can sustain, but not 20,000 or 30,000, but 10,000 it can sustain. How to get the same resolution at lower voltages? Then we need to develop the technology with which we are emitting electrons. Rather than thermionic emission, we now use field emission. You know, who first discovered the emission of electrons from the metallic substrate? Metallic circuit. Who discovered that? So, because when you enter into the room where SEM is there, probably no, or YC, you can go YC college. There is a SEM. You enter into that SEM room. Look at the electron beam. But there, when you look at that, when you try to understand how you get the images out of this SEM, you should simultaneously know the basic things that you learned in F5 Who invented that particular phenomenon where electrons are ejected from metal by applying the field? Who? Or by applying or shining the light. Very well known scientist, very well known phenomenon. तुम्ही असं म्हणू नका मला सर आम्ही केमिस्ट्रीचे आम्हाला फिजिक्स माहिती. This is photoelectric effect. Einstein. Correct. Albert Einstein got Nobel Prize for photoelectric effect. What was that? If you shine the light on the metallic surface, and if the energy of the light is greater than the barrier height, work function, then the electrons are ejected from the metal. You cannot see the electrons, but you can detect the electrons. Just by detecting the energy of the electrons, he draw one particular graph, which is energy of the electrons ejected versus energy of the light incident. And then that was a straight line. And if you extrapolate the straight line to the y-axis, that gives you work function. And if you take the slope of this particular graph, you calculate Planck's constant. First year ला झालं ना, एक्सपेरियन्स झालाय तुम्हाला, विसरायचं नाही. फर्स्ट इयरचं जर्नल सर आता कोण कधी लिहिलं होतं, मी आता कुठेतरी टाकून दिलंय, काढून बघा. When you are a researcher, you need to go back and see your notes from 11th standard onwards. Probably, sometimes I have a habit of reading CBSE, my child's books and notebooks which are there in 8th and 9th and 10th standard. Some basic ideas. Anyway, I don't know how much time I have, but sir has to go. I can keep on telling you, but I didn't tell you anything about the nanotechnology. But this is the tool that is required for nanotechnology, because you can visualize the nano things with the help of the machines called as SEM, FESM, TEM. TEM is far ahead, transmission electron microscope. What exactly is the difference between FESM and TEM then? FESM, I told you, only 10 kilovolt. But field emission, it has got same magnification and resolution. TEM, what is TEM? Only difference is the voltage. Can you imagine the voltage that we apply in transmission electron microscope? There is again a pipe, there is again an electron emitter, there is a detector, everything is same. Only thing is that we need to apply the higher magnitude of the accelerating voltage. Can you imagine how much voltage we are applying? 300 kV. मग अशी 30 होतं, एक मॅग्निट्यूड वाढलं, एक झाले 300 K, 3 म्हणजे किती होते? 3 लाख. 300 K, 3 लाख. 3 लाख व्होल्टेज आम्ही त्या बीमला लावतोय आणि त्याचे इलेक्ट्रॉन इतक्या वेगानं बाहेर पडताय की कोणत्याही सॅम्पल मधून ट्रान्समिट होतात आणि तो ट्रान्समिशन स्पेक्ट्रम आपण बघतोय. विथ द हेल्प ऑफ दॅट यू कॅन सी द atoms of the material that you have synthesized in your lab. It is possible that it is so powerful. Now there are atoms, but what to do with that atoms and molecules which we can see with the help of TEM. For that, many resource persons are here. Very big scientist, Professor Shezwar sir has invited today, and probably they will be able to tell you more. I did not have time to prepare PowerPoints, so I told yesterday, sir, I will not be able to. I have many thousands of PowerPoints, but even I don't have time to select which PowerPoint, and I don't think that the PowerPoint presentation that I prepared last year is useful today. It is changing, and the mind is changing, knowledge is changing, landscape is changing, everything is changing, so I don't want to prepare the slides at all. So today we are here to talk about, I am also I am very happy that you are energy and environmental application. Environment. Chemistry and physics people are now talking about the environment because it is now needed. Earlier, environment science, it is not our piece of cake. Only environmental scientists are working on the environment science. Today, we have to bother about the environment because though we have come out, we have won the battle against COVID-19, there is one more problem and danger that is knocking at the door, but we are not aware. As a scientist, we have developed that particular perspective that tomorrow this problem will come. It is like a slow poisoning, therefore we are not understood. We are not imagined how big or how complicated problem that is knocking at the door. Tomorrow it will be dangerous. That is climate change. That is global warming. Several thousands of years back, the average global temperature of the earth was constant. Who made it constant? Nature has certain ecosystem that the average global temperature of the earth did not change by a single degree for the last 1,000 years. You understood it? And everything, nature has circulated, which has an ecosystem that regulated the temperature. Like this, we are sitting in the room. Who is regulating the temperature? AC. We have specialized instrument here. AC is regulating the temperature. But who is regulating the temperature of the earth? Nature. It's very complicated, but there is a nature. And we are blessed that there is a certain accumulation of the gases above us in the upper atmosphere. They are absorbing certain highly energetic radiations which are emitted by the sun, and they are absorbing there outside in the upper atmosphere without we noticing. But they are working for us. If they stop working for us, then X-rays and gamma rays, even ultraviolet rays will reach us and we will be in trouble. There will be skin cancer and many other things. There will be no light if there are no gases in the upper atmosphere. The gases like ozone, oxygen, these gases are there which are monovalent like oxygen, OO, OOO, that is O3, ozone. All these gases, nitrogen, NM, they have so very high energy frequency, higher vibrating frequency that they absorb higher energetic radiations emitted by the sun. Gamma ray X-rays are absorbed by them. So you should be thankful, you should be worshipping oxygen and nitrogen and ozone. They are real God for us. They are real God who has pushed that particular gases in the atmosphere? No. No one. It is a nature. Nature has automatically adjusted the concentration of the gases in the upper atmosphere so that they are just enough to absorb these highly energetic radiations. Otherwise, we will be in a problem. There will be no life on the earth. But there is a window. Ultraviolet absorption. Visible, there is a window. Just like we prepare a tea and we filter a tea. Just like there is a filtration of the electromagnetic radiations in the upper atmosphere. Nature or God has made our upper atmosphere in such a nice manner that it is filtering the radiations which are harmful to us, which are absorbing, which are filtering only that is required for us, like visible. Without visible radiation, we cannot see. The things are not visualized because of visible radiation. No. That is filtered out and we are reaching. Those are reaching on the surface of the earth. Some sort of NIR radiations are also there. So there is a heat because of the NIR radiations. But now, the filtration is disturbed. Ozone layer is disturbed sometimes. I was talking about the average global temperature of the earth was constant. Now, we know that there was some industrial revolution. Industrial revolution required energy, and for getting energy, we are burning coal, oil, and gas for several hundreds of years. We are just burning, and creating that into the energy. We did not bother about the byproduct, that is dangerous CO2, that is emitting continuously. And now, up till now, there was no problem. But now there is a problem. 300 ppm concentration was CO2 concentration in the upper atmosphere. Now it has gone up to 400, and because of that, the average global temperature of the earth, which was constant for 1,000 years, is now increasing. 1 degree Celsius was the rise in the global average temperature. That is the problem. So we had to take care of this climate change. We had to take care of the global warming. How to take care? Sir, it is very big problem. How I can do for that? Every single person is responsible for that, and today we have to work. There is no alternative. So each and every research should be focused on sustainable societies and sustainable development. शाश्वत विकास आज सगळ्यात महत्त्वाचा आहे. What is sustainable development? I will tell you one definition and I will stop. Sustainable development is to make the world a better place for everyone. Simple है माना sir. AC लावूया better होतंय. Sustainable development is to make the world a better place for everyone, comma, without destroying the possibilities for the next generation. That is problem. Next generation, your children, your grandchildren may suffer. The quality of the air that we breathe today should remain the same for the next 50 years. Is it possible? No. Why not possible? Write down. How it will be possible? Write down. And if you don't agree, write down. Sir, the quality of the air that we breathe today will remain safe for the next 50 years. Write down. And think. And discuss with the scientists. Discuss with the experts. Now the quality of the water that we drink today should remain same for the next 50 years. Is it possible? Just think. There can be only 3 answers. No. Quality will not change. Quality will change. You write down and then you discuss with your teacher. Or you think and you can ask your Google teacher. You start getting some knowledge from the WhatsApp University. Good knowledge is there. Okay. So now getting answer is not difficult, getting question is difficult. So ask that particular question to your Google. Whether the quality of the soil with which we grow the crops today will remain same for the next 50 years? Those are the questions that we need to think about. Is the problem that we are facing with the plastic remain same for the next 50 years? Earlier when I was in the university, and sometimes I used to come to Satara, Mahabaleshwar on bicycle from Kolhapur. Many times we friend came from Kolhapur and Sangli to Mahabaleshwar on bicycle, but that time there were no plastic bottles and not bottled water was not at all the concept. We used to stop anywhere and drink any water, but that was pure. Some 30 years back. Today, can you stop anywhere and drink any water? That means quality has changed. For good or for bad? For bad. The quality of the water is degrading. Right? So, during the last 30 years, this has been changed. Next 50 years, I am talking about. Think about it. Next 50 years, what is going to happen? What is the cost of the bottle now? 10 rupees. It is going to be maybe 500 rupees. Maybe. That is my guess. I don't know. Maybe more than that. For getting the same bottle, 1 liter of water, you have to pay, you may have to pay 500 rupees. That you are paying today is only 10 rupees. Yes or no? I may be wrong. You prove me wrong. Sometimes you have to prove. But if you want to prove me wrong, I will really appreciate and give you at least 10,000 rupees as a price. Immediately today, itself now. Okay, so this is going to happen. Not we, just like myself and Shezwa sir, we are quite old now. We are going to retire. But what we are thinking about you, our next generation and next to next generation who will suffer. And therefore, this particular definition is very, very important. So tomorrow, if I want to develop a sustainable society, you have to think in this particular holistic manner. Focus entire research on that particular area only, which is going to harm us. There is only one planet. There is no other planet for us to go there. There is only planet Earth. Do we have another planet? We cannot go to another planet. Okay? So, my dear friends, probably today I have given you the message that focus and think about sustainable development, eco-friendly ways of doing the chemical processes, environmental friendly ways, environmentally benign processes. How to recycle the waste like plastic, which is dangerous, which is not biodegradable. Now the plastic is no more plastic. It is now micro and nanoplastic. If this particular bottle has a microplastic, can you judge it? No. If there is some nanoplastic, you may not notice it because they are not visible, but you are drinking it. Where it will go? If there is a biological person, I would have asked that particular person. It will go and may lead to cancer and may lead to some other deadly diseases of the future. Nobody knows because we cannot eradicate plastic, which was invented 1 year before Einstein published 5 important papers like photoelectric effect in 1905 and invention of plastic is 1904. That plastic is still dominated till today. It is dominated. Look at your house and see how many plastic waste you are throwing out. The journey of that waste you do not even know, don't know what is the journey of the plastic that you are throwing out. So today, circular economy is very, very important. Whatever the waste that you are throwing out should come in. So reduce, reuse and मोठ्याने बोला रिसायकल. अजून त्याच्या पुढे काय माहित असेल तर बोला. रिड्यूस रियूज रिसायकल बरोबर आहे तुमचं. 100 पैकी 90 मार्क. 100 पैकी 100 कोणाला देतो जर हुशार मुलगा असेल तर रिड्यूस रियूज रिसायकल आणि त्याच्या पुढे जाऊन अपसायकल. आजपासून बघा गुगलला विचारा व्हॉट इज अपसायकल, व्हॉट आर द एक्झाम्पल्स ऑफ अपसायकल्स, त्याच्यावर रिसर्च करणं गरजेचं आहे. Recycle means converting the product, the value of the end product is the same as that of the original product. Upcycle is value of the end product is probably 10-100 times more than the starting product. Is it really possible? We have to think differently. we did some experiment. I did not tell you what we all did, but we did experiment in upcycling. The plastic, some intelligent students came to me, sir, we don't really see that there is a problem of plastic waste, but we don't know what idea, what research we can do. Then we developed some nice reactor, shredded that particular bottle into small pieces, put it into some oven. It is vapor. When it is heated, some gases emitted in the closed vessel in the reactor. We allowed to throw that particular gases. There was some catalyst. There at some particular temperature, and that particular gas cracked down into graphene. So we started with the plastic, which has no value today. We end up with the graphene, which is costlier than the gold. That particular experiment is at least valid, viable, and successful in the laboratory. But now we want to upscale it. We want to scale up that particular procedure so that each and every bottle can be recycled and converted into the product like the graphene, which has a more value than the plastic. That is upside. There are many other examples that you can see from the Google and WhatsApp and internet or ChatGPT. You take that, collect that particular information. Information is the power, because we are in the information age. That particular era is very, very important. More is the information, more powerful it will be. Okay, so that is the message that I wanted to give you, and these are the two things: sustainable development and circular economy, and upcycling. These 3 points I have told you. Probably if sir invites me to next year, I will ask you the same question and take the review of the things that you have done in the next 1 year. So wish you all the best for this. Thank you so much.
How we have to be curious about our passion and use of some digital ways, Google and ChatGPT. And if you are intelligent, you can see the things that actually you can't see. And the simple definition of sustainable development, circular economics. Thank you, sir. Thank you so much. Words are powerful. They live forever and have the power to truly guide us and impact us in our lives. May I now call upon President of today's inaugural function, Principal Dr. R.B. Shezbhar sir, Principal of Lal Bahadur Shastri College of Arts, Science and Commerce, Satara, to share his inspirational thoughts with us.
Discrimination of education for knowledge, science and culture. By carrying this motto, the educational leader, the founder of this institute, Dr. Bapuji Salunke, Mata Sushila Devi Salunke, the great philosophers Swami Vivekananda and Lal Bahadur, I greet their sacred memory. Good morning to all of you. It gives me a great pleasure to welcome you for one-day international conference on nanomaterials for energy and environmental applications, which is organized by the Department of the Chemistry. I welcome the chief guest of this function, that is Honorable Professor P.S. Patil sir, Pro-Vice Chancellor of Shivaji University, Kolhapur. The chief guest of this conference, the pride of the Shivaji University, Kolhapur. Not only say pride, but the pioneer of the field of the material science and the nanotechnology. I think just I have seen what he has given without PowerPoint. He continuously gives the deliberating the lectures, not for the hours, but I think he will get the time. He will continuously talk on each and every field of the sciences. He has not given the touch to the specific nano, but all around the science. They have given the nice lecture and keynote address for this function. I have just seen that when eminent great scientists, when visited to our college, if we have seen the citation, Google citation, on this, I have seen the citation is near about 2000, but just I have clicked. It is near about 24,278. His H index is near 80 and ideal index is 424. What are we with the great scientists? How we are making the international standard scientist has the, so I am saying the pride of the Shivaji University, the Professor Pramod Patil sir has accepted our invitation and comes in our campus for the inaugural function. The invited speakers for this international conference, the Santosh Patil sir, the Femto Institute of Science and Technology France, is also the student of our chemistry department of the Shivaji University of the Kolhapur, asset of the university. Asset of the university goes abroad in the France and also in South Korea, in different university, and he makes the relations of the India with the France and the South Korea and works with the scientific temper in the different fields. He will give a full explanation about their environmental aspects and some energy related problems, energy creation, energy batteries, new types of the energy batteries, that is more storage, how can making the more storage of the batteries related. We have known that we are using the mobile phones and the prompt mobile, having the more and more life period of the mobile. It depends on the life period of the battery. How the life period of the battery can be increased. Here in the life period of the battery, there are the anodes and cathodes. Which type of the materials we have to use for its increasing the life period of the battery. He is making the work. I have asked him that what about here we are coming for the environmental problems here. There is solid waste of these batteries. What we are doing? They are saying that I am working. This is my interest. My interest of this topic, that is the recycling process. Saying recycling of the batteries. How we can remove these materials which are used in that battery and how that can be used. So recycling of the batteries is also the problem of the India. India is facing the solid waste management, liquid waste management, and he has also giving the solution. Here also the next speaker, that is the Thaila Shivakumar Natarajan, scientist of the Environmental Science Laboratory, Chennai. Also the Naresh Kutia, University of the Norway. Also the Dr. Srinivas, National Chaitung University, Taiwan. Today they are giving the giving the lectures in the next sessions. We have known that this is the offline and the online, both hybrid mode international conference. International abroad, so many scientists are giving the lectures in this conference. It is my pleasure that on this occasion I have to introduce my Samstha within few words, because Swami Vivekananda Shikshan Samstha is established by the Dr. Bapuji Salunkhe in 1954. With the motto upliftment of the downtrodden society. Now it has near about 400 culture centers among the 13 districts of the Maharashtra and some part of the Karnataka. And one of the Lal Bahadur Shastri College is the one of the premier institute of the Swami Vivekananda Shikshan Samstha. It is established in 1967 with the 200 students, and now there are near about 6,000 students are studying in this college. And it is my pleasure that is in third cycle of the NAC, college has get the status 3.15, that is accreditation. Also college has the community college status, DST FISC status, also the DBT star status. That is DBT star, the Department of the Biotechnology has given the 1.04 crore rupees for the establishment of the science laboratories. Also the 50 lakhs rupees we are getting from the Department of the Science and Technology, and near about the 2.2 crore rupees from the community college from the University Grant Commission. So here we are knowing that this college performs so many programs from undergraduate to the postgraduates. In my college there will be the some post-graduation in Marathi, Hindi, also in economics, and also in English, the post-graduation in commerce, also MCom, and also in the science faculty there is the in chemistry, organic and analytical, and also the zoology. PG research recognition labs for the chemistry and the zoology. There about 25 students are performing the research in this campus. Now here, why we are taking this international conference, sir has told us that is the energy main problem, nanomaterials for the energy and environmental applications. Now energy problems, we have known that the crisis of the energy. This nanotechnology has the potential to transform the energy sector by taking the advantages of the unique properties of the nanomaterials. How these nanomaterials can be used to prepare the more and more abundant amount of energy. Sir has told us that what we are using, the coal, burning of the coal is the main source of the energy of this country. And by that burning of the coal, the atmosphere, air pollution, more and more carbon. We are knowing that developing countries and developed countries emits the carbon in the environment, and there will be the pollution problems. The carbon, that is carbon dioxide, sulfur dioxide, definitely carbon monoxide, so many poisonous gases. So there will be the air pollution and the drastic effects makes on the human beings. That is the acid rains. The global warming, sir has told that the global warming, what we are giving to the next generation, that is pure water. Can you see that we are giving the pure water to the next generation? We are giving the pure earth, land. What our parents, we are given this land, same type of the land we are giving to your child. What? So the pollution problem is the fundamental problem, and researchers have given the more and more attention towards the pollution problem and environmental problem. That will be the pollution. It is related with the air pollution. We have known that the air pollution. See that so many, near about the 40 countries having the any teeny particle size more than 2.5 micrometers in smaller in length. 48 industries of the country, cities are more than 10 times higher than World Health Organization has reported us that. And how these fiber particles can be removed? What will be the new sources? Can nanoparticles can take interest in this to remove the air pollution? There is the problem, there is the challenge to the students of the researchers, either physics or the chemistry. Sir has said that break the compartments of the all subjects. At a molecular level, physics students, chemistry students, biological students come together and save our environment and save to Earth. So we have to take attention towards the air pollution, water pollution. That is the water pollution. We have known that to population of the country goes on higher and higher. Near about 1.4 billion is the population of the India. And to make the more and more grains, we are cultivating hybrid varieties, and we are giving the more and more fertilizers and more pesticides, more fertilizers, more fertilizers. What is making the effects? It means that more fertilizers given to the lands, that will be the fertile lands, we will get the sandy land. The all phosphorus materials and all excessive chemicals going into the water. And in that water gets contaminated. Sir has said that we have to need this distilled water. That is the we have then no after some days how we will get the fresh water. The tremendous, we have known that 75% of on the earth is the water. But how many pure drinking water is present on this earth? So we have to save the water pollution. What is the challenges in front of the scientists? That will be the green synthesis of the nanomaterials for water treatment. The green synthesis. Yeah, researchers have taken the attraction related with the green synthesis. Catalytic activation of the oxidants. That will be the for the water treatment, advanced oxidation process and the sulfate radical based process. That will be the challenges in front of the chemist, also the physicists. Photocatalytic removal of the pollutants in water treatment. That is also the electrocatalysis for the water treatment. Santosh Patil has doing same type of the work. We will be discover. We will say something about the some removal of the pesticides, dyes, and the organics. Catalytic conversion of the carbon dioxide into value-added chemicals and the fuels. There will the food and the water storage problems. We have known that the waste management, solid waste, liquid waste, how we can nanomaterials, how we can take the how we can overcome these all types of the pollutions. So nanotechnology offers new and improved environmental technologies such as nanosensors, nano devices, nanofilters, nanorobotics for the detection of the contaminated in the groundwater, toxic metal contamination, and industrial wastewater purification. I think so many persons, so many eminent persons are giving the lectures on this. So all researchers, all students should attract to save the environment. How we can, what will be my participation for this conference? So sir has said, come to the conference, attend the lectures. You will get the small idea. You will become the creator. Don't follow us. Don't follow us. Ask to the you are saying, sir has said that in earlier days, what were the for the references? We have to go to the libraries. We have so many 1 year. You have to we have to see the references in the library for 1 year. For the applying the research problem to finding the research problem, we have to meet some experts, expertise human beings. But now there will be so many advantages. We are getting the Google and Google Teacher. Sir has said Google Teacher, and after that Google Teacher, sir has given the Chat GPT. Ask to the Chat GPT or what type of the references are there. So immediately we are getting the answers. We'll select the problem and its answer will be, we will get the immediately answer, and you can think over it. Think over it. Sir has said that what will be visible. You can, with your mind, you can see that invisible things and invisible research, and that invisible research is fruitful for the saving the environment and for fruitfulness of the human beings. I think this international conference will be helpful for a new generation as being creators, but don't be followers. That I think every domain has said every domain has the opportunity. Definitely, you can see whatever education is manifestation of perfection already present in the man. In your man, you can find yourself. Which type of the domain is hidden in between you? You are a physicist, you are a chemist, or you are a biologist. You can think over it and exploit it and develop it. Definitely, your opportunity will get. You will get definitely a powerful opportunity, and this will help to giving the more idea for the startups and which develop your country. I thankful once again for all dignitaries, all the resource persons, and also for the collaboration activity done by our Department of the Chemistry, IPSC, with Kolhapur Institute of the Technology. Dr. Kamble sir is here. Along with the sir says that the engineering field, autonomous colleges and the basic science colleges may come together and collaborate with each other. Whatever be the knowledge, it should be converted into the engineering field, and which will be the helpful, fruitful for the human beings. And this human beings model is save the environment, save the pollution, and gives some problem which is fruitful for the human being. I think best wishes for this my conference, and I thankful all Professor P.S. Patil sir, and also for all dignitaries on the dais and all dignitaries and participants from the globe. Thank you once again. Thank you all of you, and best wishes.
Thank you, sir, for sharing your precious thoughts. Thanking is a great tradition of any function, and for that, I would like to request Dr. C.P. Mane sir, Vice Chairman, ICNIA 2023, to give a vote of thanks.
Honorable Principal Dr. Shejwar sir, Honorable Vice Chancellor Professor Dr. P.S. Patil sir, Dr. Santosh Patil sir, Dr. Ganesh Kamble, and all my colleagues and participant friends. I am here for vote of thanks. I am thankful to Honorable Pro Vice Chancellor Dr. P.S. Patil sir for sharing their valuable time for ourselves and guiding the participants of the conference with very knowledgeable talk. In his talk, he focused on importance of interdisciplinary research work. They guided us and they said that the student must be curious, then and then they can do the good research. Curiosity of student must be his passion. Sir focused on challenges and excitements in the research education. Sir shared all their experiences about his research work, which can encourage all the young ones. Sir is the idol for all students and researchers. Then I am thankful to management of KIT College of Engineering, and especially my research colleague Dr. Ganesh Kamble for their active collaboration in conference. I am thankful to Honorable Principal Dr. R.V. Shejwar sir for to give opportunity to organize the conference and to encourage us for to conduct the conference. I am thankful to Dr. Santosh Patil sir for their presence in the conference as a resource person. I am thankful to all the participants who actively participated in conference. Without the presence of participants, there should not be a success of the conference. I am thankful to all my staff members who directly or indirectly helped us for the grand success of the conference. I am again thankful for all the non-teaching staff who directly or indirectly helped to organize the conference. On behalf of Honorable Principal and Organizing Committee, I declare that the program of valedictory function is over. The further session of conference will start soon. Thank you. Thank you very much.
Immediately we are starting the first session of the Dr. Santosh Patil from Femto IT Institute of France.
We will now proceed to the session first. We have an exciting lineup of invited talks. We are also excited to listen them. For this session, we have Dr. Santosh Patil, a renowned scientist from Femto Institute, Science and Technology, France. Topic of his talk is hybrid nanomaterials for energy and environmental applications. The chairperson for this session is Dr. G.S. Kamble sir. May I call both of them on dais? I request Chairperson Dr. G.S. Kamble sir to felicitate our guest, Dr. Santosh Patil. Please take your seats.
Hello.
We will now proceed to the session first. We have an exciting lineup of invited talks. We are also excited to listen them. For this session, we have Dr. Santosh Patil, a renowned scientist from Femto Institute, Science and Technology, France. Topic of his talk is hybrid nanomaterials for energy and environmental applications. The chairperson for this session is Dr. R.B. Hangarke sir. May I call both of them on dais? I request Chairperson Dr. R.B. Hangarke sir to felicitate our guest, Dr. Santosh Patil. I request Chairperson Dr. R.B. Hangarke sir to felicitate our guest, Dr. Santosh Patil. I request Chairperson Dr. R.B. Hangarke sir to introduce our guest.
Good afternoon, all. So, I am very happy to introduce today's resource person, Dr. Santosh Patil sir. Now, presently he is working as a postdoctoral research scientist from Department of Applied Mechanics, Femto ST Institute, Western France. Sir has completed his MSc in Organic Chemistry from Shivaji University, Kolhapur, and PhD from the same university. Title of the thesis is a fabrication of hierarchical nanostructure composite materials and their photocatalytic applications under the guidance of Professor S.S. Kolekar sir and Dr. B.B. Kale sir from the CIMET. Sir has completed his postdoc also, research on development of new nanomaterials, nanocatalysts, semiconductor, photoelectrodes, and assessment of the potentialities of these materials for energy-related applications. Sir is presently working in a Femto Institute based on France. Prior to that, sir also started his career from September 2016 to 2018 as a South Korea. Then afterwards, sir also worked in the different departments like Department of Chemical Engineering from the South Korea again, September 2021 to August 2022 from the South Korea again, and presently sir is working in the France. Sir also on his record has many awards like a Best Paper Award in the National Conference. Also sir got the Research Fellowship and Award for International Researchers sponsored by QBTIC, Bilkent University, Ankara, Turkey. Best Speech Award in a high school level competition. And search in area of interest is, research interest is experience in synthesis, assembly and applications of nanoparticles, semiconductors, nanostructures, petrostructures and graphene, nanohybrid using chemical, physical and electrochemical processes. He is also interested in artificial photosynthesis for future energy carriers production like green hydrogen production, semiconductor photocatalysis for environmental pollution, abatement, water treatment and so many things. Electrocatalysis, energy storage, lithium-ion battery, supercapacitor, electrochemical detection and nitrobenzyl. Sir also work as a mentor PhD students like at INNA and KNU University, Joanne Lee and Park, so somewhat difficult names. At Shivaji University also Rachna Gaware. For master students, the same like Taewon Kim, Sangyeon Moon and some bachelor students also at CIMET. Saili Jain. Some studies have some important skills like experience in nanomaterial synthesis, excellent knowledge of nanocrystal, significant hands-on experience with EV visible FTIR-PL spectroscopy, experience with analytical techniques such as GC and HPLC, expertise in different microscopes such as FE-SEM-10, well versed in material analysis techniques including XRD, XPS, EGS, and area of interest, research area of interest is nanotechnology, photo, electrochemistry, energy materials, and hydrogen energy. Sir is having H index 21 and attain index is 36 and citations is 1573 with publications 80. So I request, this is a brief introduction about Santosh sir. I request Santosh sir to deliver his speech. I welcome Santosh.
First of all, a very good morning to all of you, and thank you, sir, for such a nice introduction. So, it is my great pleasure and honor to be here, and first of all, I would like to congratulate all the participants and the organizing committee for such a wonderful conference here, basically international conference. So when I see at you, I saw that you are very young, creative minds of this country. You are very energetic, and whenever I go to the colleges, I have given several lectures to the colleges. So I usually talk about what are the career opportunities for the students going abroad in the research. So here, my today's talk we will discuss about, this is very focused and it's a part of conference, so I will talk about the related to my topic. And at the end of the session, if you have any questions and if you want to know more about the career opportunities, you can ask or you can talk me later. So here I would like to be very interactive session because I don't want to make you bored for this session, and I know that this conference are very important. So why we go for the conference? So basically to make the context, and we go to the conference because when I was in South Korea, So when I met one senior scientist from South Korea, so he is a retired scientist. So when I asked him, sir, how this guy became a very big fellow, like a director of this CSIR laboratory, then he told me that he just attended the conference. So I was quite wondering why, how this is possible, just attending the conference. He is reaching out to the a pinnacle kind of, I mean, very high level position in the laboratory. So he told me that he attended the conferences and he made the several contacts with the big fellows in the country, and that helped him to grow fast than us. So that means conferences are very important. Here we can to share the knowledge, to meet the people, and to get around, we can get the more knowledge about the researches and the opportunities, and of course the context. So here my name is just Santosh Patil. So I'm from Femtoist Institute Science and Technology from Besançon, France. This is one of the wonderful city in France, located at the Switzerland border, and very beautiful. So here, this is my institute, Femtoist. So Femtoist stands for, Femtoist means it's kind of a joint institution which has several departments, like the name is French Comté, Electronics, Mechanics, Thermal Science, Optics, Science and Technologies. So the French Comté means the region where the institute is located, and it has the departments of electronics, mechanics, thermal science, optics, science and technology. So here is the web page. This is if you want to know more about the institute, you can check this web page and know about the institute, what are the ongoing research projects in the institute, and also you can look for the different opportunities and open positions available for the students, master students, and for the PhD. You can know more about this web page. So in this talk, I will be talking about the hybrid nanomaterials particularly for energy and environmental applications. So here, I have been doing research in the synthesis, assembly, and application of nanoparticles, semiconductor nanostructures, graphene nanohybrids, and various other nanomaterials for and then fine-tuning the optical, catalytic, and electrical properties of those nanomaterials for the specific applications like artificial photosynthesis for the future energy carrier generation. For example, hydrogen production from the water S2S. So I will discuss one by one how we can make the hybrid nanomaterials and how we can apply this for the different applications. So here, as you can see, I have started work with the glass. We have developed several various hybrid nanomaterials and applied for various applications. For example, I started working on this optical, we have generated chalcogenide glasses. Glass, you all know about the glasses. We can embed the materials into the glass and we can tune the particle sizes, we can tune the optical properties by optimizing the bandgap of those materials. And these materials, I mean the glass catalyst, I will talk about in the next slides. Also, I have done some experiments on the solid state reactions, particularly nanospace confined reactions. So here, nanospace confined reactions means we use some nanospace reaction media. For example, as a nano-sized reaction media, that is silica nanoparticles, and we can embed some materials, and by inducing high temperature solid state reactions, we can tune the crystal structure, composition, and properties of those materials. And also, I will talk about how hybrid materials can be synthesized and applied for the water treatment. Just in the last keynote speaker, he also talked about the environmental the sustainable development and energy. So the water treatment is very important and is a big issue. So I will be talking about that and how hybrid materials can be applied for this particular application. Then we have developed several nanostructures, basically semiconductor-based nanostructures based on the gallium nitride and zinc oxide, bismuth vanadate, and we have prepared some hybrid materials and that we are used for the photoelectrochemical applications. So photoelectrochemical water splitting applications to produce the green hydrogen synthesis. And I will also talk about the hybrid nanostructures of bismuth vanadate and graphene oxide for the supercapacitor and lithium-ion battery application. So we will see about, and also I will talk about the anodic growth of one-dimensional nanostructures. So these are very popular because of their nano application. So we will see in the next slides one by one. So before was the brief outline of our presentation. So before going to the next slide, I would like to talk about some general introduction, the general background for this research. I mean, what is the motivation? So motivation is very important. So the biggest motivation for this research is the energy crisis. So as you already know that, the energy is the big problem. So facing all world. So this is the night image of our planet Earth. So to power the Earth, we need a lot of the energy, and this energy should be sustainable and environmentally denied. So how to make and how to produce the energy? So most of the energy and what are our power needs? So if you look at here, in the last century, if you can consider the energy use, and in the next century the energy use, in the middle of 21st century, the need for energy will be very high. So we need huge energy. So most of this energy is now coming from the oil, natural gases, coal, and nuclear fission. So this energy is again what we are using is mostly generating the carbon dioxide. So that again lead to the pollution problems. So we have to think about some alternative sources of energy. So what could be the possible alternatives for this energy? So one of the possible alternatives is hydrogen. So why hydrogen? It's very important. Why we should go for the hydrogen? Hydrogen energy. So recently our government, maybe you might have known about this recent news, that our government has sanctioned a big money for the hydrogen, green hydrogen production mission, that is about for the production, utilization of this green hydrogen. So green hydrogen is important because it is 100% clean. It's in cycles of generation and utilization. Again, it can be produced from very natural resources. For example, the H2S gas, it is industrial waste, and also it can be produced from the water. So water is abundantly available on our planet, so we can use it, split into hydrogen and oxygen, and we can use those gases via pipelines, and we can make use to power the various appliances, and we can make use of it. Also, the carbon neutrality. So it has various. Hydrogen can address various societal drivers. For example, it can lower the petroleum dependence. Also, it can help maintain the air quality and make the better society. And also, we can go for the balance of, we can make balance of this energy. And when we talk about the hydrogen, so depending upon the hydrogen production, so you might have heard about these terms. What is green hydrogen, what is blue hydrogen, and what is grey hydrogen. Okay, we will see one by one. So green hydrogen means the hydrogen which is produced from the electrocatalysis of water or thermochemical water splitting, which generally uses clean electricity and generated from the wind power or solar power or hydropower, nuclear energy. So the hydrogen which is generated, and during this process if there is net zero gas emission, then that hydrogen we call it as a green hydrogen, okay? And how about the blue hydrogen? Blue hydrogen means here, as you know that industrially the hydrogen currently is produced from the water gas shift reaction, where the I will talk about this in a minute. So that generates the carbon dioxide, and when we capture this hydrogen, then because this when we capture that CO2 generated during this hydrogen synthesis, then we call it as a blue hydrogen, okay? And what is gray hydrogen? So most of the hydrogen now what we are using is gray hydrogen, because that is produced from the industrially by the steam reforming and water gas shift reaction, where methane and steam is combined to produce the hydrogen. So when we don't capture the carbon dioxide generated during this hydrogen synthesis, then there is gray hydrogen. So let us see what are the different parts for the hydrogen production. So here hydrogen can be produced industrially by steam reformation and water gas shift reaction. However, this process has a problem that it generates the carbon dioxide, so which can makes the pollution, and it is not good. So that is the reason why we need to think about some sustainable and other alternative ways to produce the hydrogen. So what are those? So it can be produced by thermolysis. So hydrogen can be produced by electrolysis, and it can be produced by photolysis. So here the water splitting into the hydrogen is the process. By using the solar light, we can split the water molecules, and this is one of the popular way, and this is going to be very popular because of the cost of it is very cost effective and low cost. So it requires 37 kilojoule of energy to split the water into the hydrogen. So for the solar hydrogen production, again there are three ways that you can use to split the water. So first one is the method of photovoltaic electrolysis. So PV. This method is you can see in this first one. So in the first figure, where the photovoltaics, this is a good method to produce the hydrogen, but it has the problem is the problem is that it requires the high cost, and we need to use solar panels to produce this hydrogen and high cost catalyst. So that is the problem. So another method is the photocatalytic water splitting. So in the photocatalytic water splitting, I will next how does this process works actually. And in this process, the photocatalyst powders. Photocatalysts are basically semiconductors. They are suspended into the water, and when you expose this to the light, so the process happens and produces the hydrogen. So this process is cost effective, but it is giving the very low efficiency. So we need to think about some another ways. So another method that you can use to produce hydrogen is photoelectrochemical water splitting. So in the photoelectrochemical water splitting, what you are doing, you use some electrodes as a cathode and anode, and then you basically they are made of the semiconductors, and here in this figure you can see third one, the cathode and anode, they are act as a catalyst for this reaction to split the hydrogen on the cathode and produce the hydrogen on the cathode and oxygen on the anode. So this pure process has its limitations, and also it has its own advantages and disadvantages. So let me tell you that. Could you please move to the next slide? So, in the broad perspective, if you look at this figure, is that clean fuel technology. I mean, we need some to produce the clean fuels production by using the electrocatalysis. So there are still some unsolved problems or issues in the electrocatalysis. One of them is the water electrolysis. So in this process, the problem of this is that it requires to achieve the higher efficiency, the catalysts are very expensive. As you know that the platinum and iridium oxide, ruthenium oxide, those catalysts are very expensive. So what we basically need is we need to produce some materials which are earth abundant, which are low cost, and it can produce the higher amount of hydrogen at the and the scale. We can go to the scale. So what is that in this here I would like to talk about, with more increasing number of solar panels on the family houses, and as well as the installation or implementation of the wind farms or solar farms. So large amount of energy is produced. I mean, I'm talking about the electrical energy generated from these processes. So what we need some solution, or we need to think about urgently something that to store this energy that is generated in the solar farms or for the wind farms, and we can make use of this energy by this process of electrocatalysis to split water into hydrogen and oxygen, and that hydrogen and oxygen we can accumulate it by using the high pressure tanks into the cylinders, and we can also transport it through the pipelines to the areas in the cities. So we need to think about something like that, and we need to find about the solution for the large perspective. And one more thing is that we produce the hydrogen and oxygen gas through the electrocatalysis. What we can do with that, we can use it as a fuel for fuel cell. You know about the fuel cells. The fuel cells can produce the electricity as long as you feed the fuels. So what are the fuels? Are the hydrogen and oxygen. So you can use these fuels, and by using the fuel cell technology, you again recycle the you again go for the electricity. Okay, so you can again produce electricity, and that can be used to power the electronic appliances. So I personally strongly believe that the hydrogen energy for the future, it is very possible, because the major problem for the hydrogen is that its cost. Its cost is higher than the gasoline, what we are using. So we need to think about the lower down the cost. So, and the good news is that the cost is reducing. This is because of development of new technologies. The cost is going down and down day by day. So in the coming future, we can see, and you already have seen that the people have run the aircrafts by using hydrogen. People have run the trains by using hydrogen. People have run the cars. Toyota is the best example. They already have the cars with the fuel hydrogen. So it is possible, and what we need to do is that we need some very scalable solution to produce the cheaper hydrogen. So this is very, very essential. Please, excuse me. Sir. Move to the next slide. So let us see. I will try to explain one by one. So I will try to explain about the photocatalysis. This is one of the popular way to split the water molecule into the oxygen and hydrogen. So most of the students are here. So I would like to make it simple as much as possible. So it's not working. So what is photocatalysis? So photocatalysis is the process which uses light in order to activate the catalyst. Okay, it is one of the green process, sustainable process, and that uses the light to activate the catalyst. So what are the catalysts in this process? They are semiconductors. So semiconductor means they have band gap. So what is band gap? Band gap is the energy difference between the valence band and conduction band. So when you have a semiconductor as the catalyst, and when you expose it to the light, you excite the electron from valence band to the conduction band, and creating a hole in the valence band, which is highly oxidizing. So this reacts with the water molecules and produces the hydrogen ion and oxygen gas. At the same time, the electrons, which are highly reducing, which reacts with the hydrogen ions and produce the hydrogen gas. So this is what is happening in this process of photocatalytic water splitting. So whether you want to make use of the electrons for the reduction or holes for the oxidation, you need to make sure that the formed electron and holes should be captured by targeted molecules very quickly. This is because if they recombine, there will be no reaction. And this is very, very critical in the design of new material. So overall efficiency of this process depends upon the material properties. Material properties are the chemical properties, physical properties, electrical properties, okay? And how well one can separate this formed electron and holes for the reaction. This is very critical because if they recombine, there will be no reaction, and this is very, very essential to be make use of these charge carriers for the reactions. So another last but not least, that is the efficient absorption of light. This is because if there is no light, there will be no reaction. And even if your material shows the 100% photonic efficiency and there is no light, there will be no reaction. So we need the light. So what I would like to tell you about is most of the research in this field is mainly focused upon new material design. So people are talking about what is new material, there is new material and new material and new material. But what is we can use the existing materials and we can re-innovate or we can modify those, make the hybrids by using the materials, and we can apply it to achieve the higher efficiencies. And this is what is going on in the research. So why we need hybrid nanocatalysts? So this topic is very related to the hybrid nanomaterials. So most of the single phase materials, they have their own limitations. Limitations, we can take one example of if you consider for the photocatalysis application. So if you have this semiconductor with single phase materials, for example, zinc oxide, bismuth vanadate, or there is a problem of fast recombination of photoinduced charge carriers. So they have the low solar to hydrogen conversion efficiency. So this is because of their limitation. But if you combine the materials, I mean, if you produce some multi-phase materials, what you actually do is that you make some interface between these materials. And what is the advantage of these material interfaces is that there are, if you combine the two semiconductors with appropriate band structure, of course, you have to look for the appropriate band structure before going into the making or some synthesizing new materials. So here, when you combine two semiconductors with appropriate band energy, what you are doing, you are making interface. So with that interface, when you excite this to the light, under light excitation, what you do, you deform the electrons, they will transfer from one semiconductor to the another semiconductor in one direction. And the holes from one semiconductor's valence band to the another semiconductor valence band in another direction. So that it will reduces the chances of recombination of charge carriers. Okay, so it will solve this problem, and there are different advantages of making the heterojunction or hybrid nanomaterials. For example, you can improve the light absorption by, this is because of the two semiconductors, okay, and facilitate the charge carrier separation, and also surface reactions for the oxygen and hydrogen production can be accelerated if you make the hybrid materials. So in the next slide, we will see how we can make the new hybrid materials using different synthesis strategies and their applications. So here the major goal of this process is to achieve the higher efficiencies for the water splitting. So people have already achieved higher efficiencies for water splitting, but they have used a very expensive catalysts which are made of 3 to 5 semiconductors, indium gallium arsenide, indium nitride, something like that. Those catalysts they have used, these are splitters are very expensive. So we need to think for some another alternative catalysts which are cost effective and which can be used at a large scale. So please move to the next slide. So I would like to explain about the plastic photocatalyst. This is one of the examples of hybrid nanomaterials and their application for the hydrogen production from the S2S. Okay, so for the first time we have studied the confinement of silver phosphate and the size quantization effect of silver phosphate in the glass matrix. So the reason why we have chosen this silver phosphate is that it is one of the very interesting material. However, it has a problem. In the olden times, it was used in the photographies, silver phosphate. So this silver phosphate has a problem of photocorrosion. Photocorrosion means when you expose this material, it's yellow color material. When you expose it to the light, it becomes black. This is because of decomposition. Decomposition into silver plus or phosphate. And in order to resolve this issue, we thought that we need something to confine this particle, to stabilize this particle. And we thought about the glass matrix. So I already have experience of growing this cadmium sulfide, cadmium selenide, lead glasses, and semiconductor glasses which has different colors. So I used this technique as a melt and quench technique to produce some glassy catalyst. So here we try how to make a glass. I will show in the next video. So how to make this glass? You can see these steps 1, 2, 3, 4. These are the steps that we have followed to make the glass. So glass you already know, but you maybe know, I don't know, may not know the how to make the glass. So to make the glass we use silica, and we use some the melting point of silica is very high. It's 1800 degrees centigrade. So we need very high temperature. So the furnace that in our lab that normally works at 1500, 1400. So we add some another carbonates like sodium carbonate, zinc carbonate, and another carbonate materials in order to lower down the melting point of this silica. So here the first step is the mixing. Mix this material and your semiconductor catalyst with the powder by using the one milling machine for a long time in order to make the homogeneous mixture. And that mixture we put into the crucible which are made of alumina. It can sustain at high temperature. And when you melt that, you have to quench it in some mold which is made up of stainless steel mold. And then the formed glass is normally colorless. Okay, the formed glass is normally colorless. So what happens during the melting is that here this silver plus, it is in the ionic form, silver plus and phosphate ions, it is in the ionic form inside the glass matrix. So when you go for the high temperature annealing, it starts to crystallize. It starts to crystallize and makes the nuclei, and it starts to make some nanoparticles inside the glass. And when you anneal at high temperature, it produces the nanoparticle inside the glass matrix and it becomes the color yellow. Here you can see after annealing, the color becomes yellow. So I would like to show you something how we make the glass in our laboratory. This is very old time video in 2016 or 2015. So could you please play the video? So I would like to show you actually how this process of glass making. So in the same folder, there are two videos. It's not long, just 2 minutes. It may be interesting to you, particularly students. Minimize this and start the video. Minimize this and here is video. You have to open it. This is the big furnace, very big furnace. We produce the glass at the scale of 5 kg. It's very big glass, and we make big block and then we cut it and polish it and make into small pieces and use as optical cut-off filters. Also, we use it for the catalysis. So here you can see the operation. This is mostly automatic operation. So we have very large big crucible here, and you can see the molten mass here. So the molten mass, its temperature is very high. So we have to be very conscious while working with such a high temperature. So it is dangerous also. And we have there there is some mold. You can see square mold. So we have to pour it into the mold. So this is about the process of making glasses. So why these glasses are important is we can make use of these glasses as a cut-off filters, also for the railway signal applications. And some of them have applications in remote sensing camera and satellite. So the molten mass is poured. So if you keep it as it is, the glass will break. This is because of the stresses. So we have to transfer it to the another furnace, which is maintained at temperature around 500 degrees, which is near to the glass transition temperature, Tg. So immediately in the next slide, you will see in the next video. This is going to be transferred to the another furnace and melted. So that furnace, this is another one is small furnace where we can use the programs for the crystallization. Yes, we have to take out this mold and transfer the glass into the another furnace. Alright. Stop now. So when you transfer this glass, so we have to annihilate at high temperature, at different temperature. So depending upon the different temperature, different size nanoparticles can be grown. I will show in this presentation. Please move to the next. Yes, here you can see we have prepared the silver phosphate glass and to solve the problem of photocorrosion. And here you can see the band gap was tuned from 2.25 to 2.56 electron volt, and we studied the effect of size quantization on the photocatalytic hydrogen revolution reaction. So we tuned the particle size from 3 to 14 nanometer. So this would not be possible with some other methods. So but it can be possible by using some solid state media like glass. And here you can see the optical spectra. So for the as prepared glass, you can see the black line, there is only one absorption edge. So and when you anneal the glass, it has shown the two absorption. That is one is, you can see first hump, that is for the surface plasma resonance of the silver, and another edge is for the silver phosphate. So in this way, it has formed the silver particle and also the silver phosphate inside the glass matrix. And for the first time, we applied this for the S2S splitting. S2S splitting is important because this is one of the industrial waste, and we can waste to wealth. We can use this as a to produce the hydrogen, and it has shown excellent hydrogen evolution activity for the photocatalysis. So in another example, we have tried to synthesize the zinc oxide. So zinc oxide, it is one of the very interesting materials, but it has very wide band gap. So what in this study, what we have done is that we have used the surface plasmonic silver particles, and we try to reduce them by using some neem leaf extract. Neem, its name is, biological name is Azadirachta indica. So we have prepared some Azadirachta indica neem leaf extract, and we used as a reducing agent instead of some very hazardous sodium hydrogen hydrate or sodium borohydrate reducing agent. We use neem leaf extract to reduce the silver nanoparticles. So in this synthesis, the zinc oxide hierarchical nanostructures. Hierarchical means they grow in the three-dimensional, and they make flower-like structures. So they are very beneficial. This is because of they have large surface area, and also they can give easy access for the electrolyte ions, and give the very good efficiencies and light absorption property for this zinc oxide. So we have synthesized this zinc oxide and decorated with the silver nanoparticle. So due to the surface plasmonic effect of silver and zinc oxide, it has been applied for the photoelectrochemical application, photoelectrochemical water splitting, which has shown 2 times enhancement in the photoelectrochemical property compared to the reference zinc oxide. So this is the typical setup we have used. There is cathode and anode, and it is connected with the potentiostat, and it is also connected with the xenon lab. Also, for the this is another example of the silver phosphate. So we try to make some hybrid nanostructures of the silver phosphate by combining with the nickel ferrite. So this is because we have made some magnetically separable photocatalyst. So magnetically separable catalyst has the advantage that after the reaction, you can easily separate it, or by using applied magnetic field, you can separate the catalyst and reuse it for multiple. So for the silver phosphate, rhombic defined run-like structure, hexagonal structure, and the nickel ferrite particles, they were decorated. So how to analyze this? This is the transmission electron microscopy. So where you can see the crystal structure, and you can see the 2 different set of lattice fringes. Lattice fringes that in the transmission electron image, you can see 2 different lattice fringes for this nickel ferrite and silver phosphate, indicating that formation of heterojunction between them. And we found that the electrical conductivity also increased with using the nickel ferrite, and we applied it for the photocatalytic removal of dyes from the wastewater. So why this wastewater dyes removal is important? So it is important because, as you know, the textile industries use various dyes, and these dyes are lost during the process of manufacturing. Around 12% of these dyes were lost during the process of manufacturing and processing. So if you dump these dyes directly into the water sources, it will make the pollution, and it also lead to some cancerous diseases, very cholera-like diseases. So we need to find some solution to treat these dyes before we pass into the resources. So for that, we can use the photocatalysis process, and we can purify the water and use for the various purposes. So there is another example. Please go to the next. So in another study of silver phosphate, we coupled it with the lanthanum hydroxycarbonate. So what we have studied here, that we started with this combined hybrid nanomaterials made for made from the silver phosphate at lanthanum hydroxycarbonate. And initially, it has formed the structures like you can see here the silver phosphate that has formed the hexagonal-like structures, and lithium hydroxycarbonate it formed the spherical particles. And when you combine this, it makes some combined both the structures of this and this you can see in the composite kind of structure. So we found that by wrapping with the graphene, it can increases the electron transfer, and it is very beneficial for the photocatalytic removal of dyes from the water. And in the next, we move on to the we use some. This was all synthesized in water as a electrolyte. Okay, and when we use some mixture of water and pH, we find that these particles, spherical particles, were transformed into the nano rods of lithium hydroxycarbonate, and they were decorated on the silver phosphate, and it makes some it makes very interface, very clean interface that is very beneficial for the photocatalytic reactions. And also you can see in the TEM image, the nanorods are decorated with small particles, and it has given very interesting results for the photocatalytic removal of dyes from the water. So this is the particular example of use of catalyst, hybrid nanometal catalyst as a photocatalyst. So in the next, I will talk about use of bismuth vanadate based materials, hybrid materials for the water splitting application. So here we synthesize the bismuth vanadate by facile hydrothermal method. So hydrothermal method is a very simple method where we use the hydrothermal reactor. So hydro means water. Basically we use the water as a solvent and we give the temperature, so that's why the name is hydrothermal method. So here we use it's kind of bomb, the reactor, which we fill up to the half, and there is pressure is generated. So at high pressure, we can synthesize the nanomaterials by using this method. So we synthesize the bismuth vanadate, a particular firm-like morphology. You can see this. This was obtained with the FESM. So in the last keynote speaker, he had talked about the FESM and TEM. So FE he asked about what is field emission, and when we use the field emission, we go for the high resolution. We can obtain much better images than the normal SEM and normal. And in the transmission microscopy, why this is important, transmission electron microscopy, the poor shell nanoparticles you cannot see by SEM. So we need to go for the transmission electron microscopy, where the electrons transfer and we get the clear image. You can see interlayer, outer layer, and also core shell nanostructures can be identified. So we analyze these materials by FESM and TEM analysis, and we use these electrodes as an electrode for the production of hydrogen from the water splitting. The setup was we use the cathode and anode, and using the potentiostat and with the solar light, we can carry out the reactions, oxygen evolution and hydrogen evolution reactions. And we found that when we combine this silver and reduce the graphene oxide, it can improve much better the efficiency of this catalyst for these reactions. So here you can see there is maybe around 2 to 3 times enhancement in the photoelectrochemical properties of this material. So another interesting example of this is the bismuth vanadate tungsten oxide. So this is very popular and interesting catalyst in this field, bismuth vanadate and tungsten oxide. This is because of their type 2 band structure. In the type 2 band structure, there is electron and hole pair separation is very facile. So here, most of the previous researchers, they have studied the doping of molybdenum and tungsten into the bismuth vanadate. So it usually makes some substitutional doping. Substitutional doping means either it can substitute vanadate or either it can substitute some bismuth, and we can dope this at this particular size. But we thought that we can make use of lithium as a dopant. This is because of the small size, this tiny size, that is 0.76 angstrom and 0.80 angstrom, which is compared to the very small size, interstitial size of bismuth vanillate. So this is as per our hypothesis. So in order to test this hypothesis, we try to make use of lithium and tin as a dopant into the bismuth vanillate, and we found that how to confirm that, whether it is substitutional or whether it is interstitial. So one way to confirm the substitutional or interstitial doping. So we were very interested in the interstitial doping. So we have checked it with the XPS. So in the XPS we can see there is negative shift in the binding energy. So usually negative shift in the binding energy, it confirms that the doping is interstitial. So we found that the best result we obtained with the tin doping. It has improved the electronic conductivity, and also it has shown about 3 times enhancement by using the tin doping compared to the reference bismuth vanillate, and it has shown 2 times enhancement in we doped with the lithium. So this is the kind of example how we can make hybrid materials to improve the properties of the base materials for this kind of particular applications. So next, another example of this hybrid nano catalyst is that we try to solve here the issue of bismuth vanillate. There is some vanadium leaching out, so vanadium losses during the reactions. So how to solve this problem? So we try to make some single crystalline TiO2 by using the simple procedure we have followed, that is hydrothermal and spin coating, and we try to optimize the condition to obtain the single crystalline TiO2 layer. So what we observe is that when we coat the single crystalline TiO2 on the bismuth vanillate, the single crystalline layer behaves very differently than the previously known the amorphous TiO2. So what happens is that the single crystalline TiO2, it can improve the corrosion resistance, and also it can block some surface defects. So this has improved the good durability for this catalyst, and it has shown very excellent hydrogen evolution. As you can see here, this is the graph of hydrogen evolution with time, so continuous hydrogen evolution. So in another example of hybrid nanomaterials as a catalyst, we have developed some zinc oxide nanorods. So if you want to make the zinc oxide nanorods, the procedure is simple. You have to go with some, usually if you want to go for photoelectrochemical applications, we make use of the FTO and ITO as a substrate, because we need some conducting substrate to make the electrode. And you first coat it with we need to make, because we have to grow one-dimensional nanostructures, we have to coat with some seed layer. So seed layers is very important to make the growth in one direction. So here first zinc acetate we use, and we coat it on the substrate, and it makes, and then that substrate we use in the hydrothermal reactor. And when you use the precursors of zinc oxide, zinc, and we need some basic media, that is KOH, and when you put the substrate into the reactor as a hydrothermal bomb reactor, it makes one-dimensional nanostructures of zinc oxide. So here we try to see the effect of indium doping into the zinc oxide, and we found that with the indium doping, the charge transfer is very fast and very low resistance. The resistance is lower, and it gives the very interesting results for the photoelectrochemical water splitting. So in this first graph, in the last figure, you can see there is an incident photon to current conversion efficiency. So that gives an idea about how many photons are converted into the current, and you can clearly see here the very significant enhancement in the photocurrent. So usually the generated photocurrent is in proportion with the amount of hydrogen produced during the reaction, and here this is the typical example of this hybrid nanomaterials as a catalyst for the photoelectrochemical application. So this is another example of TiO2 based nanostructures. This kind of TiO2 nanostructures are very interesting because this has been synthesized by electrochemical anodization, And how to make it. So this is kind of top-down approach. I have heard about the top-down approach and bottom-up approach. So in the top-down approach, we start from the, we make the big something and we go for we develop the materials by using some reactions. So here we use the metal substrate as a first, and then by using two-step electrochemical anodization, in the first step we remove the outside layer, so it makes some spurts. So spurts like structure, there is something. And when you go for the next anodization, it makes the one-dimensional space nanotubes. So we intentionally made this TiO2 space nanotubes. This is because the space-to-space interspace is important. So we can mount some another materials into the interspaces, and we can create some hybrid materials. So we try to make use of, we try to synthesize bismuth vanadate by using microwave assisted method, and we have synthesized the bismuth vanadate TiO2 based hybrid nanostructures, and we have applied those as an electrode for the photoelectrochemical application. So we characterize with this by X-ray diffraction to confirm the phase formation, and also we have studied the photoelectrochemical activity for the hydrogen evolution, and we found that there is a 14-time enhancement compared to the reference TiO2. So that means there is making the structures of hybrid with the bismuth vanadate is very essential and very beneficial for the hydrogen evolution application. In another example, we have studied the TiO2 nanotubes. So we have compared these TiO2 nanotubes with their another nanoparticles of TiO2, and we try to emit this at different atmosphere, high temperature gases atmosphere, argon and oxygen. So we found that under argon annealing, we found that during the synthesis we use some fluoride solvents. So these solvents are these ions, fluorine and sulfur. They were doped into the TiO2, and they make some very visible light absorption. So visible light absorption is important to obtain to absorb more light, and if you absorb more light means more efficiency for the hydrogen evolution. So this is one of the typical example of one-dimensional nanostructures. So in the another example, that is hybrid nanomaterials synthesized with gallium nitride. Gallium nitride is one of the interesting material. But it has a problem of it has wide band gap. It cannot absorb the direct visible light. So we try to make some hybrid nanostructures of gallium nitride by combining it with the zinc oxide and multi-wall carbon nanotubes. The reason why we have used the multi-wall carbon nanotubes in this synthesis is that the multi-wall carbon nanotubes in this synthesis act as a structure directing agent, and we have synthesized a honeycomb-like structure. So honeycomb-like structures are, they are porous structures. You can see in this figure. These porous structures are very important. It can offer large surface areas, and also it can give more access or easy access for the electrolyte ions to easily pass and make the more active electroactive sites for the reactions. So we found that this multi-wall carbon nanotubes has a dual role as a structure directing agent, and another is the it can also act as a light sensitizer. It can absorb more light, and we applied it for the photoelectrochemical water splitting application, which has shown excellent results for the photoelectrochemical water splitting. So in the next, we have also recently synthesized some electrocatalysts. So electrocatalysts we have synthesized, which are made of the manganese molybdenum oxide and polyaniline. So this is the typical example of composite kind of electrocatalyst. So here we have varied the composition of manganese molybdenum oxide, and we coupled with the polyaniline and used as an electrocatalyst. So to make the story, we have compared these results of this electrocatalyst with the standard ruthenium oxide and platinum, and we found that it has shown very low ore potential and also very good, excellent water splitting result for the hydrogen evolution in the full cell application. So this is a kind of hybrid nano electrocatalyst example for the electrocatalytic hydrogen evolution. So again, the hybrid nanostructures made of silver and bismuth phenolate we have used for the supercapacitors. So here one found that when we make the symmetric supercapacitor, we found that very high specific capacitors 170 Faraday per gram and high energy density 2.63 milliwatt hour per centimeter cube and high power density for this symmetric supercapacitor. So here we are making use of silver is very important to make the hybrid, and it gives very interesting electrochemical properties, and we can use it for the electrochemical energy storage applications. So and we have also again tried to make the hybrid nanostructures by combining with the bismuth phenolate with the reduced graphene oxide, and we have first synthesized this material by hydrothermal method, and then we have coated this material on carbon cloth to make the electrodes, and that electrodes we have used to assemble the symmetric supercapacitor state, and we have tested for the electrochemical application, and we found that very excellent specific capacitance and high energy density. So here with the very good high voltage window 1.6 volt, this is good for the electrochemical application. So this is also the bismuth phenolate based hybrid nanostructures we have first time used for the as a competitive anode material for the lithium-ion battery. So batteries are very essential for our very essential now. So we have used this material as an anode, and we found we have made the full cell by using the bismuth phenolate as a anode and LiFePO4 as a cathode, and we have applied it for the lithium-ion battery, and it has shown very good capacity and very good cycling stability over 200 cycles. And also we try to make the hybrid nanostructures of bismuth phenolate with the nickel cobalt oxide and apply for the as an anode for the rechargeable lithium-ion battery. So here it has given the very good cycling stability for the and excellent capacity for the battery application. So basically the message is to how we can make use of the materials for these various diverse applications. The same material can be used for various applications. We need to, by controlling the reactions, so we have to make the chemistry, we have to control the structure, composition, properties for the to use in the various diverse applications. So our one of the feature is to how to we are trying to how our research is applicable to solve some and contribute to solve some of the problems in the society. So basically we need to design, it's very essential to design low pass catalyst, and that should be eco-friendly for the hydrogen production and also for the energy storage applications, and just contribute our knowledge for the welfare of the society. So with this, I would like to summarize this. So we have synthesized very simple nanomaterials, hybrid nanomaterials, and we apply it for the clean fuel technology, that is by electrocatalysis, photoelectrocatalysis. We have seen photoelectrochemical, photocatalytic, and also electrocatalytic applications of the hybrid nanomaterials for these applications. And the aim is to develop some synthesis strategies, and that can be applicable to design and make the large number of nanomaterials and use it for the catalytic reactions. And this purpose is to push the hydrogen energy mission and inspire the work towards the clean energy consumption. And also we are developing some electrode materials for the energy storage applications, particularly for supercapacitor, lithium-ion battery. And we have seen the different bismuth phenolate-based nanostructures, how one material can be hybrid with the various other materials and can be applicable for diverse applications. So this is all about the material science research and how we can apply this. This move to the next. So here is the list of our recent top 10 publications. Some of them are in very high-tech journals. And finally, I would like to acknowledge the support from my friends and my research supervisors, colleagues in the India and abroad for giving me opportunity to work and share the knowledge. And also I would like to thank for the organizers of this committee, Nalodi sir, and the LPS College for giving me opportunity to speak here, from here. And I wish you grand success for this conference. Wish you all the best. Thank you very much for your patience, and your questions are highly welcome.
Now the session is open for questions.
Is there any question? Sir, I have one doubt. So, what type of sources we have to use? Water sources. Shall we use atmospheric water for the generation of hydrogen?
Atmospheric water.
Means moisture.
We can use better to use the water which is available in the sources directly. So people are using the seawater also for production of the hydrogen, but they have some complex problem. I think moisture,
But
we haven't used the moisture, but
recently I have seen one technology. They are capturing the water from the surroundings and generating the hydrogen gas as a green.
I see.
And one more thing they have mentioned that if you use that seawater, it may cause catalyst poisoning.
Yes, sir.
That is the
That's
chance
true.
over there.
There are several complex processes are happening because of the salts present in the water. So that is one of the. So basic problem is that we can make use of some. If you go for the wastewater or something, and if you use now water is not a problem. The problem is that you lower down the cost of hydrogen first, actually the highest efficiency, and then this is very important, cost of the hydrogen.
One more doubt, sir.
Yes, sir.
We are using that hydrogen as a green response energy. But what would we do with the oxygen? If excess oxygen is there in the surrounding, there is a chances of getting fire. Oxygen also causes the problem.
Yes, sir. Oxygen. So we need to take care of that. We must take into account this oxygen storage. And so of course the hydrogen are also explosive.
Yes.
So this is also very important to, and also hydrogen storage is another big problem. So storage of hydrogen and oxygen is very important. So to make use of the oxygen, we can accumulate it in the cylinders, and we can make use for the medical purposes, or we can make use as a fuel for the fuel cell applications.
Thanks.
Yes, thank you.
Dr. Santosh Patil sir has delivered a very nice lecture. Sir has actually I am very fortunate to share such a service session delivered by Dr. Santosh Patil sir. Sir has highlighted many points, that is artificial photosynthesis and green hydrogen production, grey hydrogen production, and the blue hydrogen production. In his presentation, sir has covered synthesis, assembly and its applications like chalconite, glasses, optics, solid state reactions, nano-size reaction media, solid state and water treatment, semiconductor-based nanoparticles, green energy devices. Sir also explained that what our global power needs. Actually, there is a question mark, but sir has answered it very well. Sustainable hydrogen energy production, that is the current need of everyone. Cheaper catalyst for production of hydrogen. So sir has tried many attempts and published the literature, published the papers. is cheaper catalyst for production of